atomic mass. And the mass of an element is too small in order to determine its weight. Okay, so this difficulty can be overcome by expressing this atomic mass as relative mass. Relative mass means comparing the atomic mass with respect to the mass of a standard substance. Here, to determine the atomic mass, we are taking the standard substance as carbon-12 isotope. Okay, so the scale in which the scale in which the relative atomic mass is expressed, the relative atomic mass is expressed is called as atomic mass unit or AMU. Okay, atomic mass unit or AMU. 1 AMU. So 1 AMU, the atomic mass unit is 1 AMU is equal to 1 by 12th the mass of 1 AMU is equal to 1 by 12th the mass of carbon 12 atom. Okay, carbon 12 atom. And it is seen that 1 AMU is equal to, the value is 1.66056 into 10 raised to minus 24 gram. This is the value of 1 AMU. That is the weight of 1 by 12th mass of carbon 12 atom is this much. Okay, so now we can come, we have to in order to determine the atomic mass, we have to compare this value with the mass of the other elements, and we can determine the atomic mass of that particular element. Okay, and this symbol used to determine AMU is U. Okay, instead of AMU we can write U also. First, now let us take one example so we can easily understand the matter. Okay, first, how can we express the mass of hydrogen atom in AMU? Okay, now we know 1 AMU is this much. Okay, and the mass of hydrogen atom is 1.6736 into 10 raised to minus 24 gram. This is the mass of hydrogen atom. How can we convert this into U or AMU? We know 1 AMU is this much value. So, mass of hydrogen atom in AMU, in terms of AMU, will be equal to this value 10 raised to minus 24 divided by value of 1 AMU, that is 1.66056 into 10 raised to minus 24. The value is almost equal to 1.008 AMU or 1.008 U. This is the value. Okay, like this we can calculate the atomic mass of any element. Okay, and in the case of oxygen, the value is equal to 15.995 U. After calculation, the value, the atomic mass of oxygen is 15.995 U. Okay. Many elements occur in nature as the mixtures of isotopes. Okay, mixtures of isotopes. Many elements exist as the mixtures of isotopes. So, we cannot calculate the atomic mass as any one of the element. Okay, any one of the element. So, in such cases, the atomic mass is taken as the average atomic mass of the isotopes. Okay, let us take one example. In the case of chlorine exists as two isotopes as chlorine 35 and chlorine 37. Two isotopes are there for chlorine. Okay, this is having atomic mass 35U and this is having atomic mass 37U, and these are exist in the ratio 3:1. Okay, these isotopes are exist present in the ratio 3:1. So now how can we calculate the average atomic mass? So in order, the actual atomic mass will be the average atomic mass of these two isotopes. Okay, so atomic mass of chlorine is equal to, it is in the ratio 3:1. So 3 into 35 plus 1 into 37 by 3 plus 1. Okay, the value is 35.5 U. This will be the atomic mass of chlorine. So, atomic masses of many elements have fractional values. Okay, and the atomic mass of any element can be defined as the average atomic mass of an element of an atom of an element compared to the atom of carbon 12 isotope whose mass is 12U. Okay, so the average relative mass of an atom. Okay, average relative mass of an atom of any element is the compared to an atom of carbon 12 isotope whose mass is 12U. So we are comparing with this 12U. Okay, like this we can calculate the average relative mass of an atom of any element. Okay. Next is gram atomic mass. What is gram atomic mass? Atomic mass of an element expressed in grams. Okay, atomic mass expressed in gram is called as gram atomic mass. Okay, it is also called as 1 gram atom of the element. It is also called as 1 gram atom of the element. Okay. Example, in the case of oxygen atom. Oxygen, gram atomic mass. Atomic mass of oxygen is 16U. So in terms of gram atomic mass, we can express this as 1 gram atom of oxygen. So 1 gram atom of oxygen is 16 gram. Okay. So 1 gram atom of oxygen means it is 16 gram. Now what do you mean by molecular mass? Molecular mass. It is a sum of the atomic masses of all the elements present in a molecule. Okay. Sum of the atomic masses of all elements in the molecule. Example, or element in the molecule. Okay. Example, in the case of carbon dioxide, contains carbon and 2 oxygen atoms. So the sum will be, in the case of carbon, the atomic mass is 12 plus 2 into atomic mass of oxygen is 16. So what will be the answer? 44U. Okay. That means carbon dioxide is 44 times heavier than 1/12 the mass of carbon 12 atom, because we are comparing this atomic mass with the carbon 12 atom. So it is 44 times heavier than the carbon 12 atom. Now next is formula mass. What do you mean by formula mass? This is used in the case of ionic compounds. Okay, it's the sum of the atomic masses of all elements in formula unit of the compound. Okay, sum of the atomic masses of all atoms in a formula unit. Okay, in a formula unit of the compound. Okay, for example, in the case of the formula mass of NaCl, in the case of NaCl, the atomic mass of sodium and the atomic mass of chlorine. Okay, so atomic mass of sodium is 23 and chlorine is 35.5. Okay, so the formula mass will be equal to 58.5 U. Okay, so this is the formula mass, sum of the atomic mass of all the atoms in the formula unit of the compound. Okay, next is gram molecular mass. Molecular mass expressed in gram. Molecular mass expressed in gram. Okay, example, in the case of carbon dioxide, molecular mass is 44 U. Okay, so gram molecular mass of carbon dioxide is, of carbon dioxide is 44 gram. The molecular mass expressed in gram is called as gram molecular mass. Okay.